Hello, vintage computer fans. I would like to continue my presentation of the Multitech series of educational microcomputers from the early 1980s, the Microprofessor series, by demonstrating the crown jewel of this series to you, which is the famous MPF-I plus. Some folks say MPF-1 plus, right? And I think it's really an I here, so it's the I plus. I don't know what I stands for. It might be interactive, right? So as you see, it has a gorgeous VFD display and a full alphanumeric keyboard. So this is really a full-blown development system, right? So same company that produced the more basic Microprofessor MPF-1B, which I presented in my previous videos, right? Whereas the MPF-1B you could only program in machine language, right? And tiny basic. And it had no alphanumeric display and keyboard. This one allows, even force programming, and I'm going to present the force system on this machine as well in a later video. But in this video I want to show you the two-pair symbolic assembler and basic operations of this machine. So I think Multitech, nowadays known as Acer, introduced this machine in 1983 or 1984, and it was of course a bit more pricey than the MPF-1B, but it's certainly an awesome machine. So let's start with a quick tour of the board, right? So what do we have on board? Again, we have the Zilog Z80 here. Again, not the A version, but clocked at 2 MHz, like in the MPF-1B, same processor speed, right? Then we have the monitor program here, which is in a 2764 8 kilobyte EEPROM, right? So the monitor now consumes more space than in the MPF-1B. Here you can either have a basic, and in this case it's not tiny basic, or you can have the force system. I have the force system installed here. This is another EEPROM. And I'm also going to present force and the basic, which is not a tiny basic, right? So the basic, for example, also has floating point and arrays and strings, unlike the tiny basic in the MPF-1B. And then we have 2 and 2 kilobytes of SRAM. I'm pretty sure I could also put larger SRAMs in here. Those are simply 61/16. So, and then there are two PIOs, the programmable peripheral interface chip from Intel, the 8255, which you find in numerous home computers of that area, right? C64, the Amstrad CPC, they all basically had, a PIO in there. And here we have two PIOs. So this PIO is basically responsible for driving the VFD display. It's 20 alphanumeric characters, and this one is for the expansion header if you interface with a printer or hardware extensions, because hardware extensions also exists for this machine. I also have the printer option, which I will also present in a bit in that video. And again, it has the cassette interface, the loudspeaker, the speaker LED, the halt LED, right, if the CPU encountered the halt instruction. And then this switch here is for a battery buffered RAM, right? The SRAM is battery buffered. And let me show you the back of the machine so you can see what's going on there. Carefully. So here we have, of course, the speaker. And then this is the battery pack, right, which powers the SRAM. And those batteries, they can really power the SRAM for a year or so, right? I also love the the note here: do not touch the exposed pins. Supply voltages. Connecting these pins to ground or to other pins may cause improperation or permanent damage. So careful with that. This is why I powered it down, right? So let's put it back together. And I want to start my demonstration by, starting with the basics. Like with the more basic version of this machine, the MPF-1B that I demonstrated in my previous videos, you can, start by entering machine code using the monitor. So the monitor is available with M, right? And that way you can either inspect the memory, right? Or you can also alter the memory. So let's start by keying in a little hex program. So you can either get into display mode, right, like this, and then you can conveniently step through the memory and see what's in there, right? And you can also alter the memory with the M button, and that's what I'm going to do now. So I'm entering a hex program, right, from address F100. I have the opcodes, the hex codes prepared here from my assembler. Use the Windows assembler again. And later on I'm going to show you how to use the symbolic 2-pass assembler in this machine, where you can then actually enter assembler into this machine rather than having to use your Windows assembler to get the hex codes, right? So that's the program. Let's check out what it does. G is for go to, or start the program at the given address, F100. Again, that's the sound program, and it's using one of the firmware routines again, the tone command at address 0874, and so that's the same program basically that I showed you on the Microprofessor MPF-I. So next, there's a line assembler which is already symbolic, right? So you can put in symbolic in the sense that you can put in assembler, but no symbolic labels, right? Because for this you would need the 2-pass assembler. So, but before doing this, let me show you that the memory is really battery buffered, right? So I'm pulling the plug here, and I expect the machine to still have the program when I fire it up again. So usually, 5 to 10 seconds are enough to clear all SRAM memory. And let's have a look where we entered it, right? You see we still have some bytes there. Of course they could be random, but it's actually really our program. So let's start it again. So that's really an incredibly useful feature, right? To have a battery buffered RAM in these machines. So, all right, now let's move on to the the line assembler, which is being invoked with Control L. So you specify the origin of your program, right? So let's start at F000. Then for the object code, we can also, just use F000. And now we can start by inputting assembler, right? So the symbolic version, the assembler version of the machine code program, the sound program that I just showed you, goes like this, right? So the C register just holds the tone, right, from 0 to FF, the frequency of the tone to be produced. And you see then when I hit enter, it shows you the opcode, so it's 0C for increment C. Now we load the duration of that tone into the HL register. And here you got to be careful, right, because the assemblers in this machine, they require a trailing 0 for hex numbers, right? So, and then you enter the 4-digit 16-bit hex number, right? So I want to have it sound for 8 cycles, basically. And then you also got to use an H at the end, right? So this is how you enter that hex number. Also absolute and relative addresses also have to be entered like this. And you see, so there are the opcodes 20, 08, 00, right? So now we are at address F004, and we now have in the C register the tone pitch, right, 8-bit, and in HL register we have the length, the duration of the tone, and we can now call the firmware routine, which is at address 0874 hex. Again, I use the trailing 0 and the H suffix, right? And there's the opcode CD7408, and now we just loop relative jump, right? And also for the relative jumps, now I want to jump to the beginning of the loop, right? Where the C register is incremented, and so that goes like this. 18 F7, right? So now we can leave the line assembler by simply hitting enter, and again execute our program, and this time we have it at F000. Yeah, and you see that also worked, right? And we can also check again by looking at the memory what has been produced. Works. Alright guys, let's demonstrate the symbolic 2-pairs assembler now. I've also connected the printer here now, which is the same hardware, the same printer as for the MPF-1B version, but it has a different EEPROM here, right? So that's the only difference. It's also easier to operate because, you can simply turn on the printer with Ctrl-P, and then everything that you type is being echoed basically on the display on the printer, right? For now I'm turning it off again using Ctrl-P, printer off, and we are going to use it to produce a printout of our assembler listing, and there's also the disassembler built in, right? So I demonstrated this on the MPF-1B as well. So in order to use the 2-pairs assembler, we first have to write a text file, and so you invoke the text editor cold start, right, with Ctrl-E for editor, and then you have a chance to basically specify the memory region, the text editor buffer, right? So here I'm just accepting the defaults. So this is the memory region for the text editor's buffer. And now I'm in edit mode. So you see that this is the cursor, this caret sign. And I can start by typing in my assembler program, right? So it even allows comments, right? So I'm going to put in a comment here. Semicolon counter, right? And now in order to for the 2-pairs assembler to correctly assemble, you need to follow a certain indentation strategy, right? So the symbolic labels, if you're using them, have to occur at the first cursor position, and then the assembler mnemonics have to go after tab, and even something like specifying the origin of your assembler program has to be indented correctly. So our program starts at address FB00, and now the first thing we are going to do is we are calling the clear firmware routine, which clears the display, and I'm going to define this symbolic label later in my program, right? So, and now this is our first label, loop, and we start by loading the IX register with the display buffer, which is again a label which I'm going to define later. And then, since we are implementing a counter, I'm incrementing the accumulator. Like in the MPF-1B, the firmware routines that display something, etc., are destroying the registers, so you have to save them. I'm pushing them on the stack so I can retrieve my accumulator value easily later. And I'm again calling the clear firmware routine. Next I'm calling the routine hex2, which is producing the bitmap pattern for the display, right, in the display buffer, which is then being displayed by the function scan1, which scans for keyboard input, but also displays the display pattern in the display buffer for like, half a millisecond or something like this, so we can actually see what's in the display buffer. And next I'm restoring my accumulator because it was destroyed by now, and then I'm jumping to the beginning of my loop so we can increment the counter. Now it's time to define the symbolic labels for the firmware routines. And the clear routine is at address 09B9, hexadecimal. Then our display buffer we are defining at address 0ff2c. Excuse me. The hex2 firmware routine that converts the register content of the accumulator into bitmap patterns in the display buffer is at 089AH. Then we are using scan1, which is at 029BH, and that's it for now. So in order to exit the edit mode, you just hit enter, and now this is the command line, the command input mode for the editor, like in VI basically, right? And here we can, either navigate through the editor with commands. So you can go to the top of the buffer, and then you can have a look at the editor content. So there's our counter. Let's just step through it to see if it looks good. Yeah, looks good to me. So we can now quit the editor with Q. And now we are back to the monitor top level prompt. And we can now invoke the symbolic 2-pass assembler using Ctrl A. So we can just accept the default values here. It asks for the origin of the program, right? FB00 that matches the origin that we specified in the file. So you can also specify the memory start address and end address for the symbol table, and then where the object code is going to be produced. So we are just accepting the defaults, and now the compiler is running the assembler, and you see it didn't encounter any errors. So we can also look at what it produced basically, right, by looking at the memory region with the M command as we did previously. So I think we are good to go. We can try to execute it. Go to FB00. Yeah, and you see what it is. It's just a simple counter on the display. So that worked. Now let's extend the program a little bit by also adding tone, the sound output, right? And for this we now have to re-enter the editor, right? So to resume the editor, rather than using Ctrl E as a cold start, which would clear your file, basically you're using Ctrl R, and then you're back in edit mode and you still have your file available, right? So we are going to the top of the editor file, and we now extend our program by inserting a couple of lines. So after the call scan1 and the pop of the AF register pair, now we are going to insert some more lines, and for this we are using now the insert command, and we can input our next line. So what we want to do is now we want to load the C register with a value from the accumulator, which is the counter value, right? And then again we are saying, okay, we want to have the sound duration for 20 cycles, right, in the HL register. Now we are calling, before we actually call the tone command, we have to save our accumulator counter again to the stack. And now we can call the tone subroutine in the firmware to make the sound. And that should be it. So let's step through. Call clear, call hex2, call scan1, get the accumulator back from the stack, load C with the accumulator value, load HL with 20. Okay, and save AF again, call tone, and now there should actually be one pop AF before we go back to the loop. So we can also go down right, in the pointer. Actually, that was the wrong direction. I have to go up by, say, 4 lines in the editor. And now I'm again here. So after, oh, there's some confusion now. Let's start from the top again. So there should be the call tone here, right? And then there should be a pop AF. So let's insert the call tone. Got deleted somehow. I actually used D for delete. Sorry, that wasn't down, but it was delete. So I deleted the call tone line. And now I'm also popping the register again. And now we should be good. And the jump is also missing, so in order to go up one line, I'm using up. Go up by 3 lines. And now I need to enter the loop, the jump again, jump relative to the beginning of the loop. Okay, there the labels are starting, and I need to put in one more label for the tone firmware routine. Let's go up 2 lines again. After scan, I'm now inserting tone, and this is at 0874. Okay, so there we got it. We can also produce a listing of this, by the way, using the printer. Let's do this. So if we print 20 lines, this is a P command, and our printer gets active now. And this is just a good way of, but for this I need to enable the printer again. You can also enable the printer from the editor command line mode using X. And now I'm going to print 20 lines from my listing. And it starts at the end, so I have to set the current line pointer again to the top of the buffer. And then I can print my 20 lines. And let's check our program in that way. You also notice that it's nicely indented. The indentation is right. No, it's actually longer than 20 lines, so if I hit enter I can just continue printing lines. Okay, so that looks good to me. Let's try to assemble this. So we quit the editor, turn off the printer for now, and Ctrl A for the assembler again. And the default values are still valid. I can still just hit enter here to accept the defaults. Pass 1. No arrows, pass 2. There we go. So, good to execute it. And you see that we now have sound output, and the same interesting effect as in the Microprofessor MPF-I for the firmware sound routine. You know, the lower frequencies, they require more cycles. And since the display is only updated, you know, when scan 1 is called and visible, in between it flickers because the program simply runs slower, right, for lower frequencies. So the lower the tone, the higher the accumulator value, the longer the program needs to execute one iteration of the loop body. Okay, so you can also save the editor content to tape, right? So let's re-enter the editor again using R. So I don't have a tape connected, but you can simply hit right, and it writes it to tape. So unlike the Microprofessor, the 1B version, you really have text files on tape, and you can read them back. Okay, let's quit the editor. Yeah, I already demonstrated the symbolic disassembler before, right? And of course, you can actually get a real source code listing here from the editor, but the disassembler is also available using Ctrl-D, and we can simply, like in the MPF-1B, we can simply disassemble the memory, right, by stepping through either on the display or hit Q to exit this, or on the printer. Turn on the printer again, Ctrl-D, start address, disassembler. There should also be a way to, not having to hit enter for each line by specifying some more arguments, but I forgot how. So yeah, but that's our program basically, right? That's already here, clutter basically in the memory. Yeah, and at any time I can just pull the plug and resume my work because it's battery backed up. So next time I continue my work on this machine, I can just hit Ctrl-R to resume the editor. Let's turn off the printer. And my program is still there. So this is really a very neat Z80 full-blown development system. Very useful, and you can be highly productive with this. It's really a big upgrade from the MPF-1B version. So yeah, I hope you enjoyed my video. You now know how to operate a Microprofessor MPF-1 Plus, and in my next video I'm going to show you the force. Alright guys, until then, thanks for watching.